Okay, this is section 3.5 on proving lines parallel. This ties in with section 3.2, and it's actually converse of several of those postulates. Remember, when we talk about parallel lines, we are using the symbol two parallel lines. Okay, so if first look back on page 180 and 181 in the book and look at section 3.2, example like theorem 3.1 says alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. We did alternate interior angles congruent, we did alternate exterior angles congruent, we did corresponding angles congruent, we did consecutive interior angles theorem if they are supplementary. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Okay, now this section, basically we start doing the converses. So if you look now on page 207, okay, look at postulate 3.4, says, and it's called the converse of corresponding angles postulate. The converse of the corresponding angles postulate. Okay, and that just says if two lines are cut by a transversal, so that the corresponding angles are congruent. And remember, you can abbreviate angles. Corresponding angles, use this symbol for angles. Are congruent, use the symbol for congruent. This is the symbol. Okay, then the lines are parallel. And you can use the symbol for parallel. So this is called the converse of the corresponding angles postulate. And when you're doing the assignment, use the words. Don't just say postulate 3.4. Call it the converse of the corresponding angles postulate. Postulate 3.5. Okay, it's called the parallel postulate. Okay, and the parallel postulate says if given a line and a point not on the line, there exists, and the higher you go in math, there are more symbols. Mathematicians are going to use more symbols. This is the backwards uppercase E, stands for there exists one line through that point that is parallel to the given line. Okay, and that is called the parallel postulate. If given a line and a point not on the line, there exists one line through that point that's parallel to the given line. So it's going to look like this. If you have a line and some point that's not on that line, there is one line that's parallel to the given line through that point. And remember, we would mark these then with the little red triangles to show that they are parallel. There would only be one line through that point that's parallel to the given line, and that's called the parallel postulate. Okay, and then we're going to kind of tie these together. If two lines in a plane are cut by a transversal, if two lines in a plane are cut by a transversal so that, okay, that's kind of the beginning of each one of these postulates. So that, or sorry, these would be theorems. Theorem 3.5, and it's called the alternate, and you can abbreviate it, the alternate exterior angles converse. Okay, it's called the alternate exterior angles converse. Okay, the alternate exterior angles are congruent, then the lines are parallel. So it would say if two lines in a plane are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Okay, and that's called the alternate exterior angles converse. Okay. Theorem 3.6. It would still start out if two lines in a plane are cut by a transversal so that, okay, and this one has the name consecutive interior angles converse. Okay, the consecutive interior angles converse says if two lines in a plane are cut by a transversal so that consecutive, you can abbreviate it, interior angles are supplementary then the lines are parallel. If their consecutive interior angles are supplementary, that means they have to add up to 180. Okay. Okay, remember this means they add up to 180 degrees, supplementary. Then they are parallel. Okay, and the next one is theorem 3.7. It would still start out with this beginning phrase, if two lines in a plane are cut by a transversal so that, okay, and this one's going to be called the alternate interior angles converse. Okay, and it would say the alternate interior angles are congruent, then the lines are parallel. Okay, and that's called the alternate interior angles converse. So it would say if two lines in a plane are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Okay, and the last one, theorem 3.8, and it would start out with the same thing. If two lines in a plane are cut by a transversal so that, okay, and this one is called the perpendicular transversal converse. And remember, when you're doing the homework, use these names, not the numbers. Okay, the perpendicular transversal converse, and it's in a plane. If two lines are perpendicular to the same line, then the lines are parallel. In a plane, if two lines are perpendicular to the same line, then the lines are parallel. And it would look like this. If this line and this line are both perpendicular to this line, okay, if they are both perpendicular to the same line, then those two lines are parallel. Okay? Okay, so these are basically the converse of section 3.2. Okay?